All right, let's start off here on number 14. So for this one, we first want to count up the degrees here. So I see that this one is degree 3. When it's in factored form like this, we need to add the exponents. And then I see that the leading coefficient is positive. And so I know that the end behavior is going to be, I think, like slope. So it's down to the left and up to the right. So then next up, we have my zeros, or my x-intercepts. It's whatever values make these parentheses 0. So this one would be a positive 1/2, and then negative 1, and then negative 3. Next up is the multiplicities. That's what exponent they come from. So all of these come from a multiplicity of 1. And then lastly is cut or bounce, and that's if the multiplicity is odd or even. So since these are all odd, they're all going to cut. So I'm going to go ahead and draw these here. So we got negative 3, negative 1, and positive 1/2. And I'm starting from the bottom, and then cut really means I switch to the top half, and then I switch back to the bottom half, and then I switch back to the top half. So there's my graph. All right, next up, number 16. So on this one, I see we have the first power right there, and we have the second power right there. So this will be degree 3. It's positive again, so it's going to have the same end behavior as number 14. My zeros, or my x-intercepts here, I'm going to have 1 at 0 and then 1 at 5. The 1 at 0, anytime you have a GCF of a variable, that'll always give you a x-intercept at 0. And so this one's going to be multiplicity of 1 because the exponent is 1. This one's multiplicity of 2. And so this one will be a bounce, while this one will again be a cut. Once again, that's if the multiplicity is odd or even. So I'll draw the 0 right there at 0, and then another one over here at 4, 5, okay? So at 0, we're going to cut through the x-axis. Oop, kind of missed there. Let me try that again. Okay, we're going to cut through the x-axis, so we switch to the top half. And then, since we're on the top half, when we hit the bounce, we bounce back up to the top half. So you should stay on the same side that you're on. All right, next up, number 18. So on this one, I see our degree here is 4. If we add up the exponents, the 3 and the 1. I don't have an x out front, so I'm not counting that, but this is positive, so positive even will be up and up. I think of those like parabolas. And then so our zeros here, we're going to have 1 at negative 1, and we're going to have 1 at 3. We're not going to have 1 at 0 here because although we have this coefficient out front, there's no x there, so that will not zero it out if we put a 0 there. Okay, the negative 1 is multiplicity 3, and then the 3 is multiplicity 1. However, both of those are odd, so they will both be a cut. So I have negative 1, I got positive 3. And so I'm going to start at the top half, I cut through to the bottom half, and then I cut back up to the the top half. All right, next up, number 20. So we got 2 factors here. We're going to do the degree first, so degree 2 plus 3, so that'll be 5. And then it's positive, so it's going to be down to the left and up to the right. My zeros are going to be at 1 and negative 2. The multiplicity on 1 is 2 because of the exponent. The multiplicity on negative 2 is 3 because of the exponent, which means we're going to have 1 bounce and 1 cut. All right, so I'm going to cut through the x-axis at negative 2 and then bounce off at 1, and so that'll look like that. All right, next up, number 22. So on this one, we have degree 4, and it's positive, so it's going to be up and up. I got the 4 by adding the 2 and the 2. So our zeros are going to be at 3 and negative 1. Both of them are multiplicity 2, which means they're both going to bounce. So we're going to start at the top half, and then we're going to bounce back up, and then bounce back up again. All right, this one we just need to describe the end behavior using the infinities here. And I see that whether we're looking at the p of x or the q of x here on number 38, I have degree 3 negative on either one. So that's the kind of point they're trying to make here. Although the terms after that are different, it's going to be degree 3 negative either way. So if I kind of draw this on the graph, I always think of the odds as kind of slope. So I'm going to go down to the right and up to the left. So I write that in kind of plain English here. And then I'm going to translate that to kind of this math speak. And so it doesn't really matter the order you do it in. So on this one for up, I'm going to say y goes to positive infinity. And then this one I'm going to say x goes to negative infinity. You can switch that order if you want, as long as these two are linked together. So x is negative as y is positive. And then this one would be y is negative as x is positive. So I'm just kind of doing those directions. We know that x is negative left, positive right, and then y is up, positive, down, negative. All right, number 40 here, we have, once again, we have a fifth degree, an odd degree, and that's negative. So that's going to be up to the left, down to the right. So it's actually going to be kind of the same as it was for number 38. So up left and down right. And so I'm going to say y goes to infinity as x goes to negative infinity. And then for down would be y goes to negative infinity as x goes to infinity.